An airplane has an airspeed of 430 miles per hour at a bearing of 45 degrees south of east. The wind velocity is 35 miles per hour in the direction of 30 degrees east of north. Find the ground speed and true course of the plane using vectors. So we're going to start first by noting that there's a horizontal line, because we're first talking about being south of east, right? So if we're going to the east, we're going horizontally from left to right. And from this horizontal line, we're going to determine the 45-degree angle that is going to be drawn south of this east line. And we're going to let's label this point from A to B. Okay, notice that I'm making it look like a vector with an arrowhead at the end. Okay, and this vector has a magnitude of 430, and this magnitude tells us the speed at which the airplane is traveling. However, it's not going to be the true speed and it's not going to be the true course, because there's also the wind velocity, okay, that exerts its own force on the plane. All right, and the vector associated with that will have the direction 30 east of north. So that means if we're making it look like north here, this is going to be the wind vector, right? So it has a 35 miles per hour magnitude, and we'll call this BC. So our purpose now in this problem is to find the ground speed and the true course of the plane. So that means we need to find this vector right here. So we need to find the magnitude of this vector AC, and also the angle between this AC vector and the horizontal line. We're going to be finding this angle measure ultimately, which is going to be angle X. Okay, and that will determine the true course of the plane, and the magnitude of this vector AC will determine the speed, the true speed of the plane. Okay, so where do we start? We first have to find the corresponding components of each of these vectors A, B, and AC. Notice that eventually what we're going to be doing is we're going to find the vector AC components by simply adding the AB and BC components of these two vectors, right? So basically what is going to happen is that it's going to be AB vector plus BC vector. That will give us the components of the AC vector that we're looking for. First, we need to find the components of the AB vector. How do we do this? We know that AB vector components can be found by using this right triangle that I drew right here. All right. So basically, components mean that there will be an X component and a Y component in order for this hypotenuse, so to speak. And I treat it like a hypotenuse because there's a right triangle there. Hypotenuse is always opposite of this 90-degree angle. Okay. So the horizontal component will simply be what? We're going to be taking this hypotenuse and multiply it by the cosine of 45. Right? What about this? What is this going to be? This is going to be the vertical component. So in the same way, instead of using cosine 45, we're going to multiply 430 by sine of 45. And why sine is because this side is opposite to the angle of 45 degrees right there, right? All right, so now that we have that, let's also figure out how we're going to use the components for the BC vector. Let's actually draw a separate triangle like this, in which there's a right angle right there. We know this is 30 degrees, so I'm just simulating this this triangle here because we know this was 30 degrees, right? We figured out that this was 30 degrees between the between the vertical line and this vector, because it's given to us that it's 30 degrees east of north, right? So this is the north because it's a vertical line. Treat it like a north, and then going east of that north means that you're actually drawing it to the right side. So now we need to find the components. So in the same way, we're gonna need to find the X component and the Y component. What is going to be the X component? Now, by the way, notice that I forgot one little thing here. Notice that because we're going south, I needed to actually add a minus sign there. This was like an x-axis, and when we go down, we're making the negative y, right? We're falling below the x-axis, right? So the y value must be negative. Notice that we're actually rising up and we're going to the right side. So both components should be positive. So this should be what? This should be 35 sine of 30. The vertical component must be also positive. It's going to be what? It's going to be 35 cosine of 30. We are ready to find the components for the final vector AC. Right? So the final vector AC will be basically summing up individual components. Right? When you add the vectors, you're just adding respective components. X component of the first vector with the x component of the second vector, comma, and then the y component of the first vector with the y component of the second vector. Right? So what it's going to lead to, now let's make sense of this result. Notice that in order to arrive to this point C from the given point, it's always easier to just treat it like an origin, because then you know the direction you're going positively, negatively, whichever way, right? But in this case, notice that this makes sense, because if you're starting from the origin to get to the C point of the vector AC, you need to go positively on the x, right, from the origin, so it's 321 positively, and then you're going down, right? So you would arrive here with your x component, but then you would go down to that C, right? So that means your y makes sense to be negative 273. Now it remains to find the magnitude, right? Because we want to find the true speed of the plane, right? Because this is the true vector, given that there's also a force of the wind acting on the plane. Right? So that means we're going to find the true speed of the plane by finding the magnitude of AC. Right? So the magnitude is going to be basically the square root. Notice it's going to involve a Pythagorean theorem, basically. You're going to square both of these and add them together. Why under square root is because in the Pythagorean theorem, the hypotenuse, AC in this case, was always squared, right? But if we want to solve for it, then we have to involve a square root on the other side, like b squared plus c squared, right? It must be square rooted, right? So we're square rooting that sum that is being squared to find the magnitude or the hypotenuse if you think of Pythagorean theorem. What this gives me in the calculator will be a square root of 178,334.5467, about 422 miles per hour, right? So that's the true speed of the plane, given that there's also an extra force of the wind acting on the plane. So how do we find the x? X is going to be simply, now notice, in order to find the x, you want to extend your triangle and make it bigger, this triangle, because you want the AC to be visible. Okay? So basically, notice I'm not drawing this exact triangle. I'm extending this triangle and making it bigger so that my right angle would be about here, right? I'm just extending it for the sake of picture and making it right there. Notice, speaking of the x, these sides are opposite and adjacent, and opposite and adjacent involves the tangent function, right? Trig function. So that means in order to find the x, I'm going to take the arctangent in order to solve for that angle, right? So we're going to have the arctangent of the opposite divided by the adjacent. Okay, and notice here, we don't have to think of the negative 273 because we're trying to find the positive value of the angle. And be sure that when you calculate this, you should be in the degree mode, about 40 degrees, right? About 40 degrees, right? Just like this. So how do we summarize this answer that we got? When you actually pronounce it, it sounds different. I mean, it sounds reversed than what you see right here. So basically, it means 40 degrees south of east. All right, so I hope you found this useful. Thanks for watching, and I'll see you in my other videos.